Deep Space One. Its secret is a new kind of engine, the ion drive, and it's the passion of NASA scientist Mark Raymond.
The idea for ion propulsion's been around since long before I was born, but the first time I ever heard of it was in a Star Trek episode. They're using ion propulsion, and Spock says, configuration unidentified, ion propulsion, high velocity, unique technology. And I thought, well, this is really amazing, but I'm never going to see anything like that in my lifetime.
But in 1998, Mark Raymond's dream became reality. Deep Space One. But what is it that makes the ion drive so different? Compare it with the conventional rocket. The rocket fuel burns with tremendous force, and as it thrusts down, it pushes the rocket up. In the laboratory, Mark Raymond watches a prototype ion drive in action. Instead of tons of rocket fuel, the engine uses a few grams of a gas. It gives the gas an electric charge and spits it out atom by atom at incredible speeds, creating a seemingly gentle blue haze. The ion drive doesn't have the raw power of a rocket. It has something better, staying power. It's a bit like the hare and the tortoise. Conventional rocket engines create huge thrust and awesome acceleration. But they burn through their entire fuel supply in just a few minutes. After that, it's all over. The ion drive is nowhere near as powerful. In fact, it would take Deep Space One 4 days to get from 0 to 60. But the reason Deep Space One is the fastest spacecraft ever is because it's been accelerating for almost 2 years.
When we communicate with that spacecraft out so far in the solar system, to think that our baby is out there, this little spacecraft that we built, I think it's really amazing.
Ion drive spacecraft will be fast enough to chase down comets or travel around the planets of our solar system in just a few months. But even ion drives don't last forever. Eventually they too will run out of fuel. To travel further, to reach the stars, we'll need something new. And it may be based on one of the oldest technologies we know, the sail. Long ago, the limitless power of the wind carried our ancestors to new worlds. In the future, we may use the same idea to travel to the stars. On sails that catch nothing more than sunlight. A solar sail, using only the light from our sun. Many scientists are sure that this is the future of space travel. One of them is Les Johnson.
The sun puts out photons, light. Standing here on a sailboat, the photons that are falling on us are pushing on us. But the push is so slight that we don't feel it. All the other forces around us are so much higher in magnitude that it's not noticeable. But in the vacuum of space, if you have a large enough, light enough material, the pressure that's exerted from these solar photons can cause that to move.
To see if sunlight could provide enough force to drive a sail through space, Johnson and his team built this, a man-made sun.
In front of me, we have a simulated sun, about 3 times brighter than what the sun is at the Earth, and that's the reason I'm wearing these UV protecting sunglasses, and that it could damage your eyes if I were to accidentally look right into the beam.
They're testing the ultra-thin, ultra-lightweight material they would need to make a real solar sail. It's mounted on a rod in the full glare of their artificial sun.
As you look in there, you can see it slowly rocking back and forth. What's causing that is a sunlight pressure, the photon pressure, as it's pushing on the sail.
Incredibly, it works. This piece of sail material is being moved by nothing more than light.
Based on work that's being performed around the country, solar sail technology is getting to the point where very soon we'll be flying it in space.
To reach the immense speeds needed to travel from star to star, the solar sail must start its voyage with as big a push as possible. It must fly as close as it can to the source of its power, the sun. It's a dangerous maneuver, but if it works, the craft will whip around the sun and hurtle out into space at almost 3/4 of a million kilometers an hour. A solar sail could reach the nearest stars in just decades. It's a truly impressive start, but is it enough? Our galaxy is a very big place. To get from one side to the other, even using a super-fast solar sail traveling at incredible speeds, would still take 2.5 million years. And our galaxy is only one of billions that make up our universe. This is the final frontier. If we ever want to be true star travelers, we're going to have to take a completely different approach. We're going to have to learn how to manipulate the very fabric of space itself.